week 16, like if it passes, it would be my plan on May 24th.
Well, before that, you
Yeah.
will finish, I'm sure.
Thank you.
Yeah, I think it's like 23rd, 24th. That's what
Huh?
the. Oh, we're saying I think it's like the 23rd, 24th. That's what the school is. What were you explaining to us earlier? What were you explaining to us earlier about
Oh yeah, so you have the plug, right? So right there. Okay, so you first got to solve for the poles. Did you solve for the poles yet?
No.
So if you put this function in like equals, make it equal to ns, so you just write equals to, no, the bottom one.
Oh, okay.
So
You said equal to 0?
no, ns over ds.
What?
That's,
N?
yeah, n sub s or whatever. And the parentheses s.
Oh, okay, sorry.
So you're basically saying that the top is the numerator and the bottom is the denominator. They do capital N and capital D.
Oh.
Yeah, and then to find the poles, you use ns and make it equal to 0. Yeah, so poles would be the bottom part.
And then the zeros is the top part.
Yeah.
Okay.
And then this is supposed to be your transfer function, right? So
This one? Right. Oh.
yeah, that's
This is the same thing, right?
yeah, you good. And then you make this the top part equal to 0, solve for the roots, and then the bottom part solve for the roots, and the bottom part will be the poles. Yeah.
So both each is 0.
Yeah, once you get the roots, then you basically either, because you know your roots are either going to be imaginary or real, or a little bit of both, imaginary with part of real.
And then these zeros will plot that
So
out.
basically you got to look at this right here, so depending on what you get, like, because this is the imaginary component, it's on the y-axis, and the real component's on the x.
We said both the top and the bottom equals 0, right?
0, yeah, set them both equal to 0, solve for the roots.
What's up? Yeah, I got it.
This is what's confusing the
No.
oh, he didn't press that. So I'm confusing this part. It's right here, and this one.
I just sent to the group chat.
In this example, to find the finite poles, he uses the transfer function to cover the zeros. And I think of this example, he uses
the denominator.
yeah, the denominator, but he's using the transfer function for this one. Because, right, the transfer function is...
But he's only grabbing the denominator of it.
yeah. But for the one we're doing, I think we're That's fine.
Oh, yeah, by the RS, right?
Yeah.
CS, RS.
Yes, I'm kind of confused.
Wait, yeah, I see what you're saying now. So let's see this example. So when we do this, we are looking for the poles.
Okay, so
Whatever the block diagram tells you is the transfer.
everything in here is a transfer function, but it's also CO.
Of course.
Okay.
Of course, it's also the ratio. Yes, no doubt.
I don't want to ask you because you're going to tell me to reach out.
Oh, I think, okay. I think I
Say
thought,
on the unit step function for the class
we're not, this S shouldn't be there for finding it. It should just be CFS over RFS, right?
block itself is the
Yeah.
So,
and it is because it's
Our
transferring
event is one over here, so we're going to talk about it.
yeah.
But right here is CS, like unit. So I'm just kind of confused.
I think I
Like,
wrote a typo there.
So there is a
this one or the
very important point which he has raised. You see, let's say you have a block here and block here. Let's say it is AB, and let's say this is R and this is C, right? And let's say there is a unit function here, negative, positive 1. Then it's a very important question he has raised, that if you solve it, this is AB, and then you have, R and C, right? Then you solve this one, then probably it is AB over 1 plus AB, right? This one goes here to here, C and R. Then he is saying that transfer function is C over R equal AB over 1 plus AB. Now he's asking me what is R here, R value. So remember that whatever is in the block is the transfer function. Whatever in the block is the transfer function. This is the guy who's transferring input into output. Now that's another thing, that this transfer function also represents C over R. So there are two things. When you simplify the block diagram, you will get something in the center. That is the guy, its name is transfer function because it's transferring this into this. But that's another thing, that this transfer function must be equal to ratio as well. That's why they put the ratio here. But it has nothing to do with the question. You should proceed from here. Of course, if you want to find out CT, then you need to take the Laplace of R, then they must give you R. In this case, is a unit step function, for example, right, or whatever, then they have to tell you what is R and what is C, right? So just proceed from here. But that's a confusion because the book is writing C over R equal to this, and then somebody is asking me what is R, what is the Laplace of this, and so on. So these are two things, so you have to make sure